Hey guys, my name is Frank. This is the Poth on Programming video log, and today I'm going to show you how to generate your own certificate authority, your own self-signed certificates, your own private key, all that stuff that you need to create a secure certificate chain so you can run HTTPS web servers from your own computer and be your own certificate authority so you don't have to pay some company lots of money to be a certificate authority for you. As you can see, I don't have things up and running. So I'm actually going to have to create this. I've deleted all of the certificate files and the keys that I had in my last tutorial. You saw that working with the server code that I wrote. So today I'm just going to be going over how to make these keys. So I've made a couple of bash files up for making keys. I have a bash file here for creating a private key, one here for creating a certificate signing request, another one for making a certificate itself, the certificate authority, self-signed certificate, and finally a PFX file which just bundles your private key, your CSR, and your certificate all in one, which you can then use on Android, or actually I think for my Chrome browser here I'm just using the CRT file. Anyway, you don't need all this code. This is just a bash file for my Ubuntu terminal. The important part of all these files, if I come back here to my first file that I'm going to run, the important part of this is the Openssl command that you're going to run. So Openssl is the library that you're going to use to create your private key, your certificate signing request, your certificate itself, and your PFX file. And in each one of these .sh files, I have a different command to do just that. The other two files that are really important in doing this are your certificate signing request configuration file and your certificate configuration file. So the important part of a CSR is the v3 requirement, or request, not requirement. v3 request. It is required, but it's just the v3 request section. In addition, we're going to have some stuff to input to identify who our certificate is for. But the important part here is the v3 request. And that's just going to have some basic information about our signature signing request inside of it. The important part about our certificate file, I mean, it's all fairly important, but the important part is your X509 extensions. X509 is the policy, I guess you can call it, the policy for creating good certificates, up-to-date certificates. So we're going to store our X509 policy extensions in the v3ca section of our certification configuration file. And if you want, you can just copy and paste all of this stuff into your own project. I don't expect you to learn all this just from one video that I make. That would be ridiculous. It took me hours to figure this stuff out. For some reason, to me, it's complicated. I don't know if it's complicated to other people, but for me, it's complicated. So the important thing to remember for your X509 extension is basic constraints. You want to set basic constraints to CA true. And this is the line that's going to ensure that your certificate is recognized as a certificate authority, and this is going to allow you to get that secure certificate chain, which contains in your PFX your private key, your signing request, and your certificate authority self-signed certificate. Not the best. You don't really want to use this approach, by the way. This whole approach, you don't want to use this for a website because it's a little sketchy to have your self-signed certificate. But it's fine for a test server, and that's what I'm using it for. The other thing you want in your certificate configuration file is the subject alt name, or what's known, as I've found on the internet, as just SAN, S-A-N, subject alternative name. And this allows you to have one certificate authority that points to a whole bunch of different website URLs or domain names. So for me, since I'm trying to access 192.168.101 through my router, that's the file that I'm going to be, or that's the domain name of my server, I'm going to want to include this IP 192.168.0.101 because that's where my server is going to be running. And I don't think I need this DNS, but if you want to include a DNS name, like a more qualified DNS name, you just do DNS mysite.com, and that's what it would look like. If that's the name of your website, that's what you want to include. Also, and I'm not sure if this matters anymore, but the common name, when I walk through the make certificate or make CSR, certificate signing request, common name is going to be important too. You want to match that to your domain name as well. So for me, it will be 192.168.0.101. And I'm not sure if that's important anymore, but I know it used to be important before they started using this subject alternative name. So hopefully this was a good explanation of these configuration files. I think the best way to learn for yourself is to download this source code or check it out on my GitHub and just look it over. Because I don't even know what all this stuff does. I've basically just taken bits and pieces of configuration files from other resources and pieced them together here. So without further ado, I'm going to actually run my server and see how it responds. And then I'm going to create my certificate. I'm going to create my key. I'm going to create my certificate signing request, and not in that order. So first I'm going to cd out of my secure socket layer file, which you can see right here in my file system that contains my configuration files and my other files. Actually, first what I'm going to do is I'm going to ls and see what's inside of there, see if I have anything left over from my last run of this. I actually have my certificate.pfx left in there from before I deleted everything to make this tutorial. So I'm going to rm that file and get rid of it because it's an old file that we don't want to use anymore. And now I just have the basic files that I need. I got my make files that run my Openssl commands, and I have my configuration files. So now I'm going to back out and I'm going to try to run my server. There we go. And basically what it's going to say is there's no such file or directory in SSL called crt.pfx. And if I go to my server file and I go to my server options, which is where you hand the SSL server module your certificate, it's going to look for your PFX file, or if you choose your key, your private key and your certificate file, I chose PFX. It's going to look for this, and that's what it needs to make sure everything is secure and up and running, because it uses those certificates and it accesses them via this options object right here. So I'm going to need to create this in order for my server to run, because obviously it's not running, and obviously I have no web page up and running right now. So I'm going to Control-C out of my node mon listener thing there. I'm going to cd into my SSL folder. I'm going to ls, see what I got in here, and I'm going to start out with the make key. I'm going to bring this up a little bit. I'm going to start out with my make key .sh bash file. Before you do use these files, you need to give yourself access to them from the command line. So what you're going to use is chmod u plus x and then the file name. I already chmodded all of my files, but I'm not sure if you download these, you might need to give yourself permission to access them. But anyway, these all have been chmodded, so I can use them just fine. To execute these files, I'm going to use // and then put in the name of my file. So make key .sh, and it's going to run that bash file. Now inside the make key bash file, it's just going to have a couple echo commands, which basically put the stuff you see in the string on the terminal. So as you can see, I told my bash file to output generate a private key file in PM format, blah, blah, blah. And it's going to say the same thing here, and it's going to take some input called key path, and I'm going to hand the key path value I put in to my Openssl function. And it's kind of the same setup for all these files. So I'm just going to put in key.key. You don't have to download these sh bash files and use them. You can just come in here and look at these Openssl commands. I just have this because when I was teaching myself how to do this, it was so much easier to just have this bash file and type make key.sh a million times to test it than to type this whole thing out, because it was getting really tedious to type that whole thing out. So I made these bash files, made things a lot easier. So now I have my key. And if I ls to see what's inside my folder here, you can see that I have the key.key file made. The next thing I want to create is a certificate signing request. So I'm going to use my certificate signing bash file called make certificate signing request and it's going to ask me what I want to name my certificate signing request. So I'm just going to take the prompt example, keep things simple. Here I'm going to pass in the certificate signing request configuration file, which is right here, csr.cnf. Enter the path to the private key file that I just created. It's important to create that first. And now it's going to prompt me all of these questions. If I come here to my csr.cnf, it's going to prompt me for a country name, state or province name, locality name, all these different things that is going to be displayed on my certificate. So I'm going to start with the country. I'm in the United States, Virginia. These don't really matter, but this is where I live. So, you know, if you want to find me. Organizational name, I'm going to put PopVlog. Organizational unit name, research and development. Common name. Now this is that common name I was talking about, and I'm not sure if you need to match it to your actual domain name or IP, but I am, because that was how it was before Chrome 58 came in and introduced subject alternative names. So email address, no, that is not my actual email address. So this outputs created csr.csr in your directory. So now, as you can see, I have my csr.css or CSR file in there, and if I do ls, you can see now I have my key file and I have my signing request file. The next thing we want to do is, actually first I'll give you a look at the make CSR Openssl. So really simple, and I suggest you go and get the source for this and look at it yourself. It just uses request, it hands the configuration file parameter in there, and I hand it my configuration file path. Man, hard to talk. I've been talking for like 20 minutes straight already. My tongue's getting tired. Then I make a new CSR, so I'm going to hand it the path for my private key. I'm going to hand it the inform, the type of format it's in PEM format. And then my out file is going to be the name that I hand in for my CSR. And then the out form is also going to be in PEM format. It's pretty simple. The next thing I'm going to want to do is create the actual certificate. So I'm going to use my make cert or crt.sh bash file. And this is going to generate a self-signed certificate. So enter the certificate name. This is what I want to name my certificate. Enter path to certificate configuration file. Mine is called crt.cnf. And that's right here. Enter that in. Enter path to private key file. I named that key.key. Keeping everything super simple name-wise. Enter path to CSR certificate signing request file. That's just csr.csr. Enter number of days until expiration. I'm going to put 3,000 because, you know, that's a lot of years. You could put 1 day and it will expire in a day, but I'm just putting 3,000 because whatever. Now it's going to return signature okay if everything worked out. It's going to get the certificate signing request fields that I filled in to make my signing request, which was Virginia, Radford, PopVlog, all that stuff that I just put in for my certificate signing request file. And it'll get that private key and it will create my certificate.crt file in my working directory. So now if I do ls, it will show me that I have my key still, my signing request, and my certificate.crt. Here is my new CRT file right there. Okay, now the last thing that I'm going to have to do here before I can get everything up and running is use make, what is it called? PFX.sh. And this is going to generate a public key cryptography standards number 12 PKCS number 12 file, which you can use to put your certificate authority on your Android device if you so choose, because Android only accepts either DER format rather than PEM, or PFX files or PKCS number 12 standards formatted files. So this is why I have this option. So I'm going to enter a name. I'm going to call it crt.pfx. You can call this stuff whatever you want. This is just a suggestion for what to call it. Enter path to private key file. That's my key.key. Enter path to certificate file. That's crt.crt. Enter export password. And as you can see in my server code here, I have the passphrase password. So I'm going to want to match that, or I can change this to match the password I input here. So I'm just going to say password. And you can't see it, but I am typing password. And it created my crt.pfx file in my directory. You can see that right here, crt.pfx. So now if I cd out of my SSL folder and do node mon server.js, it'll actually start my server. And if I come to my browser, I get this. See, now what I have is I have a secure connection because I'm checking my private key against my certificate or my PFX file, and it identifies that I have my key set up, and it recognizes that I have a TLS 1.2 standards certificate set up, and I have a strong key exchange, and it tells me all kinds of cool information about the type of connection I have. Then it will say I have secure resources. All resources on this page are served securely because it's serving it through that HTTPS module in my server, node server.js. The only problem I have here is that there's a certificate error. I don't have a certificate authority set up inside of my browser. So I can actually still access my content if I click advanced. This is just a warning message. I'm sure you've done this before if you've been on the web. It just says, hey, this site is not necessarily secure, but you can still go there if you want to, and I can still access it. The only problem with this is if you're trying to develop progressive web apps, you will not be able to install from home screen unless your browser is feeling nice and comfortable with your server, and obviously it is not because it is not secure. So here is how to get over this problem. We're going to open up a browser and we're going to fix this. All we need to do is install our certificate into our browser's certificate authorities file. So I'm going to come up here and I'm going to go to my settings. In Chrome, this is how you access it. I'm going to search for certificate, manage certificates. I'm going to click this. I'm going to click authorities because this is where I want my authorities to live. And by the way, this is why it's very important that in your certificate.config file, CNF file, we define basic constraints, CA true. This is certificate authority, and we set it to true. So this is what allows us to import this certificate that we just created into our certificate authorities list. So I'm going to click import, and I'm going to select my crt.crt file that I just created. And I'm going to tell my browser to trust it for basically everything. And click OK. Done. Didn't get an error message. It accepted the certificate nicely. Come over here and try to get back in. Okay, so here we go. So now I have a valid certificate. If you notice down here, now I have a valid certificate. Everything is cool. The only problem is that active content with certificate errors. So this is a problem. It's not really a problem. All you need to do is open up your browser again. You need to restart your browser to make the changes take effect properly. So if I come here and restart my browser, re-request the page, as we can see, everything comes up fine. If I go into my DevTools, I have all green lit boxes. So if you want to check out the server code that I used to get this to work, I have a tutorial on that. You could search for it. This is all the server code, or you can just, you can check it out in the source. I'm going to link to that in the description on my GitHub page. But everything we just did, everything I just showed you with my bash files here to create these certificates works. You don't need the bash files. All you need is the line behind the if statement in the bash files. You can put that directly into your terminal and create these files that you need. And it's really all you need. I like the bash files because it kind of keeps everything neat and clean. But you don't need them. But anyway, with this, you'll be able to develop progressive web apps, and you'll be able to install them from home screen when you're working on your development server, which is really, really handy. And anything else you want to do for developing over a secure server, you can use this method for. And this works for a browser newer than Chrome 58 because that's what I have. Also, this is for Ubuntu, so I'm not sure how this is going to work on other operating systems, but if you're an Ubuntu user, you're probably good to go. Anyway, I'm not sure. I think I'm gonna show you how to install this certificate also on Android. So stay tuned for that. I'm gonna have to actually switch over to my phone. I'm using my phone as a microphone right now, so stay tuned. I will have that video to you shortly. Alright, so now I am on my Android phone and I'm gonna show you how to install the crt.pfx file we just created so we can access our secure server through our browser. So if I try to search for my web page now, I don't have the certificate installed on my Android device. It's going to give me this error that says, not secure, not private. You can still get through here. You can click advanced and you can proceed to your server and get your content, but it will not be served securely, and therefore it's useless if you're trying to develop on HTTPS. So to get around that, we just need to install that. So I'm going to come up to my settings. I'm going to scroll down to security. Once in that menu, I'm going to scroll down to install from storage. Now, between these videos here, after I stopped recording on my computer and started recording on my phone, I dragged and dropped my crt.pfx file into my phone's storage in the download folder. I just hooked up my phone to my computer with a USB cable and dragged and dropped that sucker into my storage. Now it's going to ask me to enter the password that I created for my certificate, which was just password. It's the same passphrase we check for on the server. It's going to ask me to name the certificate. Has this big long default name. Doesn't really matter what you name it. Credential use, VPN, and apps. You have the choice to switch between that and Wi-Fi. I'm going to stick with VPN and apps. And everything should be good. So I'm going to click OK. And it gives you the message, big long name is installed. And now to check to see if it's really installed, we can go to Trusted Credentials. And it will be installed under the User menu. So as we can see, we have our crt.pfx file installed, and it displays the name popvlog, which we gave it when we created our certificate signing request, and it asked us for all those options. It asked us for the common name, organization, organizational unit. All the stuff that we entered when we created our CSR earlier is going to be in here. And we also have the option to remove it. One thing you might run into, if you don't have a PIN or a passphrase set up on your phone needs a pattern or a passphrase or a PIN or whatever to get into your phone once you install a user-defined certificate, which is kind of annoying. And you also get this error up here that says network may be monitored by an unknown third party. But I'm sure there's a way around it. I didn't check into it yet. I just wanted to show you how to get your development environment up and running. That's just a problem that it's not really such a big problem. I mean, probably should have passwords on your devices anyway. So now I'm going to go back into Chrome and I'm going to refresh the page and nothing happens. It's exactly the same. It's because you need to refresh Chrome, or maybe I just need to... Nope. You need to restart Chrome in order to get this to work. So I just close Chrome, I open it again, and now we should have a secure HTTPS at the top, and we do. So anyway, really simple. That's how you get that crt.pfx file onto your phone. If you're trying to get just a CRT file on there, it has to be in DER format. I didn't show you guys how to do that, but I suggest just use the PFX format. It's easy. So that's how it's done. Anyway, I hope you guys learned something. If you did, like the video, subscribe to the channel. I'm going to have more cool programming stuff coming out real soon. Some stuff on game development is in the works. So come on back and check in with me. I'll have some cool stuff for you. Anyway, guys, have a good day.